students. In this video, you're going to learn about a very important topic of organic chemistry known as Markovnikov's rule, and it's named after the Russian chemist Markovnikov. It states that in the addition of an unsymmetrical reagent to an unsymmetrical alkene, the negative part of the adding reagent goes to that carbon constituting the double bond which has least number of hydrogen atoms. Or, when an unsymmetrical alkene reacts with hydrogen halide to give alkyl halides, the hydrogen atom is added to the carbon with the greatest number of hydrogen atoms, while the halogen component is added to the carbon with the least number of hydrogen atoms. As you can see here, this is propene. This carbon has more hydrogens than this carbon. So the hydrogen part will add to this carbon, and the bromide part, that is the negative part, will add to this carbon having least number of hydrogens. So this is known as Markovnikov's rule. Now, before discussing it further, you must know inductive effect and hyperconjugation. Inductive effect states that when a bond is strongly polarized, that is, it has two different atoms joined together, it is a charge separation and is said to have a dipole moment. This permanent dipole can have an effect on adjacent bonds. The effect of this permanent dipole induced by one bond in another is called inductive effect. There are two types, positive inductive effect and negative inductive effect. Any atom or group which attracts electrons more strongly than hydrogen is said to have a negative inductive effect, that is, electron withdrawing or electron attracting, and any atom or group which attracts electrons less strongly than hydrogen is said to have a positive inductive effect, that is, electron releasing or electron repelling. Now let's see what hyperconjugation is. It is a stabilizing interaction that results from the interaction of the electrons in sigma bond, as you can see here, usually carbon-hydrogen or carbon-carbon, with an adjacent empty or partially filled p orbital or pi orbital. This interaction is known as hyperconjugation. Now let's see the stability of carbocation. It is in this order. The tertiary carbocation is more stable than secondary, which in turn is more stable than primary, and which in turn is more stable than methyl carbocation, as you can see here. Individual carbon-hydrogen bonds do not exert a particularly strong stabilizing effect. However, in the secondary carbocation, this is the secondary carbocation, there are 6 carbon-hydrogen bonds, and in tertiary there are 9 carbon-hydrogen bonds, each donating a very small amount of electron density, the sum of which amounts to a net overall stabilization relative to primary radicals, as you can see here. Because in primary radicals, there are only 3 carbon-hydrogen bonds. So the more the hyperconjugation there is, the greater the stabilization of the system. Now, let's see the formation of a carbocation. The addition of the hydrogen ion to one carbon atom in the alkene, as you can see here, what happens? It creates a positive charge on the other carbon, forming a carbocation intermediate. The chemical basis for Markovnikov's rule is the formation of the most stable carbocation during the addition process. There are two possibilities of carbocation, primary and secondary. Now, secondary is more stable. Why? Because of the positive inductive effect of 2 methyl groups. As you can see, it is flanked by 2 methyl groups and also 6 carbon-hydrogen bonds hyperconjugating. So, the secondary carbocation is more stable than primary carbocation. Carbocation intermediates make the difference. Halogens simply follow. Now you can see here, there is an addition of hydrogen bromide to propene. The product formed is 1-bromopropane? No, this is not the product formed. The actual product formed, according to Markovnikov's rule, is 2-bromopropane. As the bromide group, it will attach to that carbon having less number of hydrogens. Another example is the addition of hydrogen bromide to 2-methyl propene. As you can see here, it is substituted, the methyl group, it is substituted on the second carbon. 1, 2, 3. Now, is the product formed as 1-bromo-2-methylpropane? No, this is not the product formed. The actual product formed is 2-bromo-2-methylpropane, as the negative part will go to that carbon having less number of hydrogens. Now, there is another rule which is known as antimarkownikov's rule. In the presence of free radicals, the halogen adds first to form the radical intermediate. This radical forms on the more substituted carbon atom. The radical stability increases in the order like tertiary. Free radical, it is more stable than secondary, which is more stable than primary, which is more stable than methyl free radical, as you can see here. Again, the reason is hyperconjugation. Now students, here you see the formation of free radicals. This is peroxide, and what happens is that this free radical, it cleaves homolytically hydrogen bromide. What happens is one of the electron meets up here with this electron and forms alcohol, and the other electron jumps on this bromo group and forms bromide free radical. Now this bromide free radical, it meets up with one of the pi electron and forms a bond, and the other electron, it jumps on the carbon like you can see here and forms this radical. Now this radical, it again homolytically cleaves hydrogen bromide, and one of the electron meets up with this electron and forms this carbon hydrogen bond, and the other electron jumps on the bromo group and regenerate the bromide free radical. Now you can see here that this is the antimarkownikove addition. As a negative part, it adds to that carbon which has more number of hydrogens. I hope this video was helpful. If you like this video, please like, share, comment and subscribe. Thanks for watching. Wish you all the best.